Good morning. My name is Michael Neutze. I work for the Federal Statistical Office in Germany. And in fact, I'm responsible for the census for housing and dwellings there. 11 years ago, I had the pleasure of working at the ONS. The Federal Statistical Office of Germany is pretty much similar what ONS is here in the UK, and they sent me over to work in Alan's group for half a year, and Alan brought me in contact with SVG, and he had taught himself SVG with this book, and I swear there's a German translation of that book, and it says, teach yourself SVG in a week. So bear with me. Now, I've done choropleth maps ever since Andreas Neumann introduced us to them in 2002, and I've incrementally tried to make them better. And today's talk is about pimping the choropleth map. So let's see. This is the standard choropleth map, more or less, that we've come up with. This is the map of Germany, and you have a key and a diagram that shows you the value distribution. And you do that for a while, and for a while we just changed the underlying technology, make it work with modern browsers. But then you think, well, can it be enhanced? Do people understand it? And what would be the development? So the basic thing is when you start enhancing something, you add on top. So for instance, here we have the choropleth map, and now that we have white screen, we have more screen real estate. And since we did population pyramids anyway, why not just combine the two, and you have a choropleth map, and you go hover over that choropleth map, and you have a population pyramid on the left side that corresponds to the areas in question. And you can take this even a step further. This is not my own work. This was done by Eurostat, the Statistical Office of the European Union. And this is quite sophisticated. Just want to point out a few features. Here in the key, you can directly adjust the classification scheme by dragging and dropping. You can even go full Hans Rosling on this map because it has a scatter plot as well, and you can even animate that over time. And so you see, this is just enhancing and enhancing. The map gets smaller every time. And you see the bubbles are bubbling, but on the map, not so much is happening. And the question is, I mean, if you are doing this for 10 years, and then what am I going to present to you next year? And you would come up with something like this. And certainly, what was very helpful, there were many talks yesterday that laid the foundation for what I'm talking today. For instance, Ed Parsons yesterday said that in cartography, it's always been about taking things away, because you cannot put on a map everything that is there in reality. It's always about a decision what to take away. And so we know this from UI, from user interfaces, from designing computer interfaces. It's always about taking things away. So if we look at this, It turns out that obviously we can't get rid of the map. But then we devote a lot of screen real estate to the key and to the value distribution. And this is because we built this in the beginning, we built this for our own. We are statisticians, we are cartographers, and we thought, well, choropleth maps, I mean, they can be misleading if the classification isn't right, and we want to show people what the difference is if you have quantiles or equal distance, or, I mean, in this case, I mean, this is an election atlas from Germany, and this is a party that has a very skewed distribution regionally, and we show, well, like, where would the boundaries of those classes, where should they be, and so on. And so within our bubble, within our filter bubble, we were quite happy. But then when we went outside to ordinary people, I mean, they get that the darker the colors, the higher the values. Yeah, everybody gets that. And if you are from Germany or if you are familiar with German geography, you can understand what's going on, and the map is helping you. But we found out that when we talked to people about quantiles, about distribution, they weren't that happy. And also, what is more, they lost the basic meaning of the map. They were so focused on understanding, well, what are we doing here? Why can I input my own classification, and so on. And so the idea was to concentrate on the map and to take things out. It wasn't that we did this just to be nerdy. There was an honest statistical thinking behind it, because we thought, well, you can make a map that looks totally different, for instance, with such a different maps. And for instance, with this map, if you use quantiles as a classification scheme, you see here, you get a totally, not only do you get a totally different map, but it's misleading because you have different colors for areas that are pretty similar, and then here you have areas that differ much, and they have all the same color. And what you usually want, I mean, usually when you talk to people, they're saying, well, which of those classifications is the correct one? And so the idea was, if there was a correct one, then we could just leave that out, and the user could concentrate on the topic at hand and not on the underlying statistics. And last year, Rob Fry thankfully introduced me to Jenks natural breaks, and especially as Jenks natural breaks is available in a very nice JavaScript library. And that is an algorithm that tries to classify data so that the variation within each group is minimized and the variation between groups is maximized. And this is exactly what you want. You want to have a choropleth map where same color denotes similar areas, different colors denotes areas that are really different. So, and so with this map, I just threw the Jenks algorithm at it and tried it out. Looked really good. So the idea was we just go for Jenks and leave this part of the map, or this of the interface, we leave that out. And this is what we came up with. Again, there were some ideas introduced by Mike Bostock. For instance, he once had this beautiful minimized key, which resembles a little bit a box plot. So it shows you the value distribution. It shows you the class boundaries, but it takes up very little space, and but it conveys a lot of information, and so we went for that. And then we took out all the classification. I mean, there are some footnotes here that say, okay, we're using Jenk's natural breaks and it works like this, but we keep it out. So then the thing is, what are we doing with the screen real estate that we've won? Turns out thematic maps work very well for people who already know about the subject and know about the geography. For people who aren't familiar with the German geography, I mean, this just doesn't mean anything. Yeah? For somebody who knows that this is like Munich, and you have a suburbanized around Munich or around Berlin, and then it makes sense. But we found that people need commentary. They need text. They need commentary. And obviously, you could make screen captured video and with audio and so, but that has some drawbacks in terms of production. So the basic idea is we use this space here to give textual commentary. And the text works like this. You can just, the commentary you can just page through, and it is set up that, I mean, technically it's just a JavaScript object, but it can be edited by non-programmers, and it's such that each text block has some metadata that controls the map. For instance, this next text block has a control to zoom the map at a certain level and to pan it at a certain level. And obviously, the text can also change the topic that is displayed in the map. And within the text, there's we make use of highlighting. And since we have SVG in the browser, we can also, I mean, we can draw all shapes within HTML, and that's really nice. So what we're doing here, I'm very sorry that it's still in German, but then maybe you can concentrate on it, and hopefully at some later point in time it will get translated. But what we're doing here is we're telling people about the topic at hand, and we try to explain, for instance, in this case, why why smaller houses, or why they why certain types of housing are more common in the rural areas where it's cheaper to build than in the city with more population density. Now, you would probably still think, well, that is a weird understanding of pimping. And so, and obviously, we try to do a little bit more. One thing that has been cited quite often already at this conference is the paper Animated Transitions in Statistical Data Graphics by Jeffrey Heer. And they have shown that if you animate statistical graphics from one state into another, that this can help understanding. And we also, in 2011, Mike Bostock showed us his show reel of D3. So how you transition from one graph into another. And what you see is here you have a line graph, you have bar charts and pie charts and everything. What you don't have is a choropleth map. And the question was, can we transition the choropleth map into something? And obviously into something meaningful, hopefully. So the choropleth map shows you the regional distribution of population, of housing, and so on. What's interesting is that just like in football, you're uninterested in the teams that are kind of medium. You're interested like in the relegation, in the red lantern, at the end of the league. You're interested at the top of the league. And so whenever we have a press conference and we show census data, if we can tell, well, this is the municipality with the oldest people, with the most housing, with the cheapest, whatever, journalists are always very interested in that. And the question is, can we do this in the thematic map? And yes, we can. In D3, if you've played with it, there's this concept of selections, and within selection you can filter. And this is an easy thing to do, that you filter out the top 10s. And already this is kind of helpful that you see, okay, obviously the first thing to check is, okay, when you look at the key, the remaining parts have to be very light color and a very dark color. And you have an idea where those are. But still, this is not really what you want. And basically still, if you want a top 10, you want a bar chart. And, well, so the idea was just animate, transition from a choropleth map into a bar chart. And this is how it's done. So obviously the bar chart is interactive as well. And so you see, that you don't lose the regional context. You have the top 10, you have the lowest 10, and still if you want to see, if you're unfamiliar with a place, like want to see where that particular region is, you can hover over the bar chart. I have to admit, because yesterday Jeremy Stuckey put up these 10 commandments of animation, and I really felt ashamed because I'm violating most of them. And because this transition is semantically wrong. We have an area here that transitions into a bar. And the length of the bar and the extent of the area are totally unrelated. Yeah? So semantically, I'm doing something wrong when at the stage where I transition from the area into a bar, because if the area is large and the bar is small, and the bar can be small for a variable that is totally unrelated to the size of that area, you get a different transition than in other cases. However, with regional distribution, you very often have metaphors like a north-south divide, an east-west divide. And this is something that you get. We've learned about this concept of object constancy. And let me show you again. So here you see that, for instance, this one bar moved to the top, but most of the top bars were already in the north. Yeah, they were in fact in the northwest. And so the movement of the bars, you can get some idea. Second thing, second thing is, so, I mean, this transition, it is somehow, it's a wow effect. It should make people interested in, and obviously I'm honest and tell you that it is somehow not semantically correct, but then, I mean, if people get excited or get interested in the topic, I think it's well worth the effort. Second thing is, in regional distributions, usually you understand them, well, why people are interested in choropleth maps is because they have a pre-existing knowledge of other variables. Typically you have a, I don't know, an election map of the US, and when you interpret this, you already know where the densely populated areas, where the rural areas are, and you immediately get it. Ah, election results in rural areas are like this, or in the south they are like this. And the same is here, but if you don't have this pre-existing knowledge, the thematic map doesn't make any sense to you. And it is that a lot of variables are dependent on population density, or they may be dependent on other factors. But population density is a typical one. And what we wanted to show is that we want to introduce people to the concept of correlation, but without using the word, because it shouldn't sound as going back to school and teach them a statistics course. So what we are doing here now is that we had a thematic map of housing, and that map had a strong correlation with population density. And again, this is a concept that Mike Bostock once used in the New York Times with election results in New York City. And it is adapted here. So what we can do is that currently we only see densely populated areas, areas that have at least 1,500 person per square kilometer. And this filter we can adjust. And we think we also have here kind of a triangle that should subtly tell people that we are filtering the variable that is displayed. And so if people play with this slider, they see, okay, now I have a thematic map of small freestanding buildings, and currently areas are shown that have at least 36 person per square kilometer, which is the lowest value in Germany. And now when I increase that value, even people who aren't familiar can find out, okay, now I've filtered out very low populated areas, and still there are areas with different housing, with a different housing situation remaining, but I increase again, and there are only, those are the densely populated cities, and there's a different housing structure there remaining, because you mostly have only the the lighter colors left. It is, I have to admit, it's a difficult to explain concept. We tried it out. What I can recommend is that really in this process, you just, every now and then, you take a fresh colleague who hasn't seen this again, sit him or her down for 10 minutes, let them play with them and explain to you what they are seeing. And so we improved it a lot with this process, and we found that still this concept not everybody got. But it is such that if you start the map, you don't get this filter UI, because we want people in the beginning to have a very easy approach to the topic, and then make it more difficult when they proceed in this guided tour. Yeah, so those are the big concepts. There are a lot of smaller things that you wouldn't think of as pimping, but that I want to highlight here. If you have an interactive graphic like this, the map or graph can have, can have very different states. And what you want is that if people share this map, if they send the URL via Twitter, via email to someone else, you want that they get exactly the same. So what we are doing here is whenever you change something, the filter, the topic, the zoom, the pan, all these attributes get rewritten in the URL. And this is something where you spend a lot of time thinking about it and implementing it. And it's something that is really difficult to demo. But in the long run, I think it is necessary, and it is very helpful that you, for instance, in a press release, because here there are like 20 maps in this, 20 topics, and there are so many, maybe you want to focus on one area, or also that just people like to share it. Yeah? And so it's important that if they share the graph, that it looks exactly the same, and that they don't use a screenshot of it. Just because I have some time left, I wanted to show you what the process was like. I told you that, well, there was this paper from Jeffrey Hare about animation and so on. I have to be honest, cause and effect was quite reversed. What happened here was that I saw something like this, and I thought, well, that's interesting, and I want to use that. And luckily, I found afterwards this paper from Jeffrey Hare that I could say, well, there's a scientific explanation why this makes sense. And I tried to make as much sense out of it as possible. But when you're really, into vectors and into the D3 stuff, this is just something that you want to do. Also, I wanted to encourage you to iterate and to use your colleagues as guinea pigs so that you get input, because you yourself aren't the best test person because you've invented these things. And again, last year in Scott Murray's workshop, we had D3 selections, and he told us about filtering. And so the idea was, for me, I thought, well, filtering is really interesting in a thematic map to highlight, for instance, the top 10 values. And the interesting stuff is with D3, you filter DOM nodes. So the first thing, when I did the filtering, it looked like this. Yeah, it was stenciled out. And then came the bars. And also yesterday we learned that animations can get tedious. And this is what was done in the beginning because I liked them so much. I made them really slow, but in the end, you can't stand it. And you really have go from seconds to milliseconds to make it all work. But this stencil effect was a bit difficult because the question was, like, how could I reverse it, and where would those areas that are not the top 10, where would they go? I mean, it's just doesn't really make sense that the map moves out. So there was a different idea here. Again, filtering, making the bar chart out of it, and then have a third option where you could have the bar chart and the map side by side. But having these three options one after another, it's just too complicated, and so we tried to condense that. Yeah, so this is about it, and there's still some minutes left for questions and answers.
Yes.
So essentially the way it works is the text controls the map and you're telling a story essentially.
Yeah, I wouldn't say storytelling, because yesterday we learned that the story has an arc. I'd say it's commentary, yeah? And we try to build the commentary one page on the other and make it even more complicated, just like in a textbook, yeah? That you start with the easy stuff and get more and more complicated as you progress, but it's not really a story. It doesn't have a cliffhanger and so on.
It's essentially it's a kind of a, well, not hard coded, but it's a one directional process that new things appear as you click the next button. And
well, but what you can do is you can break out of the guided tour at any time. Yeah. Right. So, for instance, you can display. You can display different topics, and sorry, this is German. So it just says to continue the guided tour, use the page forward buttons. Yeah. So you can break out of, and also what is really important, as we don't use cookies because that's not very liked in our office. But so we don't know if somebody sees the graphic for the first time or for the 10th time. And so what we provide here is that you can skip. This means skip the guided tour. And so because in the beginning, there are some UI elements like the filtering that are hidden and that get revealed, I don't know, at page 7 or page 8. And if you are a returning customer, you can just skip the guided tour and all the features are active. And yeah. And also, as I said, I mean, we are rewriting the URL. So if you are at some stage, you could bookmark that stage and get back to it and start from that process.
If I try and use something like that, is that a struggle? Or?
No, it's not a struggle. It's just a smaller screen. And I would suggest that this is just something that's, I mean, it works great on a tablet, but I just think that it's not the right, I mean, even if you think of Napoleon's march to Moscow, the Minard graph, I don't know really if you want such a graph to be responsive to a phone. I could see that for some graphs, like a population pyramid, to display them on a phone-sized screen, that makes sense. It totally works, and it depends on your eyesight how much you can make out of it. But I guess it's not something that I would target.
Yeah. Just a small thing. Your colours here you've got a discrete colour map, right? Yeah. So when you do that transition for the top 10 and the bottom 10 to the bar chart, all of the bars at the top are coloured the same colour.
That's not necessarily the case. It's just the top 10 bars. It might be there are some variables where the top 10 values, yeah, that there might be two colors, yeah. But we have, these are 412 areas, so mostly the top 10 have the same color, yeah.
And then in those bar charts, you've got the numbers down the left-hand side, which are mapped to the length of the bar chart.
Yes, yes. It's just because sometimes the values are very close, and then people like want to see why is, or sometimes they are at the same, they have the same level, and people want to see like how much difference is there between the top 10.
You almost wonder where you need the bars at all if you've got the numbers, do you?
Yeah, well, obviously, but I think the bars get things across a lot better. So, I mean, the numbers are more the second thought. David?
The use of filters to kind of allow people to explore correlation is a real interesting idea. And you said that some people didn't get it, but I was wondering if you actually gave them a list of variables for which they could do a partial regression and look at the plot of the regression residuals, might it give a similar conveyance of understanding to the non-literate, non-statistician?
Well, the thing is, we give several variables to try out, but we carefully select it because, for instance, we have a map of owner-occupied dwellings, and owner-occupied dwellings are highly correlated with areas with a high high percentage of foreigners. But it's not the foreigners who own these dwellings. Yeah? It's just that in areas where the percentage of foreigners is high, those are prosperous areas. And this is why in those prosperous areas people own their dwellings. And so this is a kind of correlation where there's not causation. And so we didn't want to confuse people and tell them that. So we just left those variables out. And we had, I could show you in our iteration process, we had some variant where we showed the correlation coefficient and so on. And some people, I mean, it improved the understanding for some people, but I mean, in the end, you have to decide what you want to put in and leave out, and well, the correlation coefficient was left out, yeah.
I'm thinking that a choropleth plot of the regression residuals might give more information than a filter.
Okay. Yeah, I have to think about it. Thank you. So I guess I'm already stealing the next minutes from Alan, and thank you very much, and I give it to Alan.